let's understand transpose of a matrix. What is the transpose? Well, if you have a matrix A, the transpose of a matrix is denoted by A with a superscript T for transpose. Okay, what is a transpose? A transpose is matrix A with rows and columns interchanged. So the rows of A will become the columns of A transpose. The rows of A transpose will become the columns of the columns of A will become the rows of A transpose. So for example, if A is 2, 3, 1, 4, A transpose will be take the row 2, 3 and make it into a column. Similarly, take this row and make it into a column. Okay, this is A transpose. If you take a 3 by 3 matrix, okay, this is a 3 by 3 matrix, and A transpose, if that is A, then A transpose will be, or let's call this B, and write B transpose as take this row, make this 4 minus 1 3, 5 1 minus 4. I hope you are able to see that. Now the idea is that if A is m by n, then A transpose is n by m. I have shown only square matrices, but we can also write, okay, let's say C is 1 2 4 2 minus 1 3. This is a 2 by 3 matrix. C transpose will have a different order, right? So this is going to be 1 2, right? So this is 3, this is 2 by 3, and this is 3 by 2. Okay. Now if A is a square matrix like I've shown here, 2 by 2, etc., then A transpose has the same order. Let's look at some properties of transpose. Okay, the transpose operation. The first property is, if you take a matrix A, take its transpose and take the transpose of that matrix, you will get back the original matrix. Okay, that is fairly obvious. If you change rows to columns, then again change columns to rows, you will again get the original matrix. Okay. Now if B is equal to A transpose, please remember, then Bij equals Aj. So if B is the transpose of A, then the ijth element of B, which is denoted by small bij, will be the jith element of A. This also means that the diagonal entries where I and j are equal, so 1 1, 2 2, etc., those entries will not change their value when you do the transpose, even for a matrix like this. So this is C11, this is C22. In C transpose, this is C transpose 1 1 and 2 2. You can see that the values are the same, right? Okay. Next is A plus B, the whole transpose. Right? If you add two matrices and then do a transpose, that's the same as doing the transpose and then adding. Well, why? Because these are both of the same order. Aij plus Bij whole transpose. Okay, you are doing A transpose means this will become Aj. B transpose, the elements will become Bji. If you add, you will get Aj plus Bji, which is going to be A plus B the whole transposes element. Similarly, you will have A minus B the whole transpose is A transpose minus B transpose. Okay, but the most important is the multiplication idea. If you multiply two matrices and then want to take the transpose. Now remember, in order for multiplication to be true, you must have something like A is m into n and B is N into Q. Okay, then AB, let's say C is AB, C will be M by Q because the N is the common thing, right? Now, but what will happen to AB, the whole transpose? C transpose will be Q by M, please understand. So which means definitely we can't say it is A transpose, B transpose for many reasons. One is A transpose is N by M, B transpose is Q by N. Okay, now A transpose times B transpose may not even be possible because M and Q need not be equal, right? So that means this is not correct. Okay, so what is the correct expansion? Well, you can see that now if you multiply B transpose with A transpose, the multiplication is possible, Q by N and N by M. So this is possible, but this is not a proof that these two are exactly equal. For that, what you need to do is we need to understand that Cij, which is if C is AB, right, this is sigma k is equal to 1 to n aik times bkj, correct? This is the definition of matrix multiplication. This is how we multiply. Now if you take C transpose, so C transpose will be, let's say D is C transpose, Dji will be Cij. So now you can see that Dji, which is what is there in the left hand side, AB, the whole transpose, AB is C, its transpose is D, you will get Dji, which will be this. But this is equivalent to multiplying, so you can write Dji is sigma k is equal to 1 to n aik bkj. You can simply write this, just change the order, bkj into aik, right? Now this way, correct, bkj into aik. But what is bkj? So if you take the transpose of B, then bkj will become bjk and this will become bki. So it will be similar to the matrix multiplication, which is what will happen if you take B transpose times A transpose. Well, I haven't given like a full rigorous proof, but I hope you can see that first of all the order wise this matches, and if you write the expressions you can see that because ij becomes ji, it does give an expression similar to what you will get if you do B transpose times A transpose. Okay, so these are some of the properties of the transpose operation.